Hi, I'm Bob Welds, and this is a first look at welding. Welding is a process that turns two pieces of material into one piece of material. Gluing, brazing, and soldering just stick different materials together. But when you weld, the separate pieces actually become a single piece. This is done in two different ways. Either the materials are made liquid and then solidify together, or the materials are joined by forcing them together with a lot of pressure and sometimes heat. The melting type of welding is called fusion welding, and the heat and/or pressure method is called solid-state welding. There are lots of ways of doing both of these, and let's look at a few of them. Today we'll look at some fusion welding processes because they're the most popular. The most obvious way to get a material into the liquid state is to heat it up and melt it. But you can also use solvents to melt a material. In fact, you may have done welding and not even known it. When you use PVC pipe cement, you're actually turning two pieces of plastic into one by dissolving them and letting them re-solidify as one piece. But I have a feeling that you're wanting to know about welding metals, so let's look at that. Melting metals takes a lot of energy, and that energy needs to be focused on the small area we want to melt. One of the simplest ways of doing this is to take a fuel like acetylene and mix it with oxygen. Now this produces a very hot flame. The flame heats up both parts of the metal we want to join. The metal in these parts is called the base metal. The base metal of these parts melts and forms puddles. And these two puddles coalesce or run together into a single puddle. The welder moves the flame down the joint, and as the puddle solidifies, the two parts become a single part. Many times, it takes some extra metal to make a good joint. In this case, a piece of wire is dipped into the molten metal. It melts and becomes part of the weld. This metal is called filler metal, and it helps make a joint stronger by providing additional material. Using oxygen and acetylene to weld in this way is called the oxy-fuel gas welding, or OFW method. Now, electricity is another way to melt metal. The most common type of welding that uses electricity is called arc welding. Now, there are three kinds of arc welding that are the most popular. Now, these are shielded metal arc welding, or SMAW, also called stick welding. And there is gas metal arc welding, or GMAW, usually called MIG. And there is gas tungsten arc welding, or GTAW, which is called TIG. We'll keep calling these stick, MIG, and TIG for short. All three of these welding processes use a powerful arc of electricity to heat the metal to the melting point. The arc is like a miniature lightning bolt between the base metal and the piece of metal on the torch called an electrode. Now, in stick and MIG welding, the electrode is designed to melt and become filler metal in the joint. In TIG welding, the electrode is made of tungsten. You grind it to a point and you put it in the electrode holder or torch. Now, tungsten has a very high melting point, and the arc isn't able to melt it. The arc just dances off the end of the electrode while it melts the base metal. If you're TIG welding and you want to use filler metal, you add it separately, dipping it in the weld pool just like you would with oxy-fuel gas welding. A stick welding electrode looks like a little bar of metal about a foot long with a covering on it. You hold a stick electrode in a holder that has a clamp on it. In MIG welding, the electrode is actually a long spool of wire that's usually a little less than a millimeter in diameter. The MIG electrode is fed through a tube and comes out when you pull the trigger on the welding gun or torch. Now, I should tell you that when you heat metals up to the melting point, they tend to react badly with oxygen, water vapor, and other things in the atmosphere. And when this happens, the weld becomes terribly weak and porous, so it's hardly welding at all. So to keep the weld pure, clean, and strong, a shielding gas is necessary. In stick welding, the shielding gas comes from a covering that is all around the electrode. When this covering gets hot, it creates a cloud of shielding gas that protects the weld from contaminants. It also leaves behind a covering called slag that continues to protect the weld while it cools. And when the metal cools, this layer of slag has to be removed. In TIG and MIG welding, the shielding gas comes from a compressed gas cylinder. These cylinders store the gas at very high pressure, often thousands of pounds per square inch. One of the most common types of shielding gas is argon, sometimes mixed with carbon dioxide or other gases. And this gas flows through a hose and comes out right at the point of the arc. When you're done, there's no slag or other residue. But sometimes you may need to clean up a little spatter, which is tiny drops of metal that may have stuck to the base metal. Well, that's a quick look at the world of welding. If you want to know more, just let me know. I'm Bob Welds, and these are Weld Notes.